Everything is fine, sir?
हाँ चलिए. Hi guys, this is Saurav here and welcome to this JEE Advanced session for liquid solutions. In this session we would be discussing questions related to on the level of JEE Advanced and questions liquid solutions के ऊपर रहेंगे, जिसके ऊपर हमने mains level का भी quiz कर लिया है. And I hope you have been benefited by whatever we have discussed until now. तो liquid solutions chapter is almost has come to an end. ये आज last session है and last class like जो schedule था, I was not able to take it because of bad health. So I'm very sorry for that. But मेंस की क्विज पहले कर दें सर एडवांस से. मेंस की क्विज हो चुकी है. वी हैव ऑलरेडी डन, लास्ट क्लास में हमने कर लिया था. हेलो अमनदीप, आई एम फाइन, थैंक यू. सो आई होप यू गाइज हैव बीन वॉचिंग वॉट एवर वी हैव डन अंटिल नाउ एंड लिक्विड सॉल्यूशंस के ऊपर क्वेश्चन सॉल्व किया होगा आपने. ओके, लिक्विड सॉल्यूशंस टॉपिक बहुत इजी है. जेईई एडवांस में भी बहुत इजी क्वेश्चंस आते हैं. हाउएवर at times what they do is they will mix liquid solutions with some other topics to just make it a little challenging. Okay, so let's start today's session. But before that, let me tell you that please do join our Telegram group. You can like discuss questions over there. You can interact with the teachers over there. You can tag your teachers. There are a lot of amazing things which are going on the Telegram group. Please do join the Telegram group. Purely academic in content and the best Telegram group that is there. Okay, also please don't forget to like, share and subscribe our channel. Please do like videos, the ones that you are watching. Please do subscribe to the channel. Please do tell your friends. Also hit the bell icon so that you are always updated with the best content that is out there. Okay, so with this, let's start today's session. Let's start today's session with the first question. ये first question हमने last class में दिया था. I hope you had tried to solve this. Let's work out this question. Okay, so आप इस question को देख लीजिए. Question is, for the given phase diagram, which of the following is or are correct? For the given phase diagram, I had earlier explained what is a phase diagram. A phase diagram is a pressure versus temperature. States of matter exist. Okay, and by convention, I had told you earlier that this part is solid and this part is liquid and this part is gas. ये हमने बता दिया था कि if I take any substance state existing within the container, तो अगर मैं ये टेम्परेचर और ये प्रेशर लेता हूं तो हमारे पास सॉलिड स्टेट रहेगा. अगर if I take the same pressure and I increase the temperature to this point T dash, I will have a gaseous state. So what do we observe over here is a phase diagram. What do these bold lines tell us? The bold lines tell us a condition where pressure and temperature condition where different phases are in equilibrium with each other. तो ये solid है, ये liquid है. This temperature T dash and this pressure P dash is where solid is in equilibrium with liquid. Okay, solid is in equilibrium with liquid. अब इस क्वेश्चन को सॉल्व करने की कोशिश करते हैं. Okay, let's try to solve this question. Question is this: curve 1 is for a substance whose D solid, D represents density, is more than D liquid. How do we solve this question? So what I do is, and you should always solve such questions in this manner. So ये temperature axis है. I take a temperature T and I take a pressure P. Okay, I take a temperature T and I take a pressure P. Now if I increase pressure by keeping the temperature constant, मैं temperature को constant रखता हूं, मैं pressure को increase करता हूं. So I increase the pressure and I reach a pressure P dash. Okay, I reach the pressure P dash. What do I observe? What do I observe? Earlier I was in a state of equilibrium between solid and liquid, but जैसे ही मैंने temperature constant रख के pressure को P से P dash किया, I have reached a state of liquid. Okay, I have reached the state of liquid, or I have reached the liquid phase. Now let's apply the shortly a principle. Okay, so I have solid which is in equilibrium with liquid. Okay, I have solid which is in equilibrium with liquid. If I increase the pressure, what will happen? What Le Chatelet principle tells us that if I increase the pressure, the system will move in that direction in which volume decreases. Isn't it? When I increase the pressure, the system moves in that direction in which volume decreases. So pressure increase करने पे volume decrease होना चाहिए. Now अगर हम ये वाला system लेते हैं, okay, if I take this system and I'm increasing the pressure, I am getting liquid state. So equilibrium किधर move कर रहा है? Forward की तरफ. In this case, equilibrium is moving in the direction from solid to liquid. Okay, equilibrium is moving in the direction from solid to liquid. तो हम क्या कह सकते हैं कि for this plot, volume of liquid is less than volume of solid. Can I say this? I am increasing the pressure, equation or equilibrium is shifted in the direction of liquid क्योंकि liquid मिल गया है मुझे. So can I say that V liquid is less than V solid because increase in pressure favors decrease in volume. Increase in pressure prefers decrease in volume. So volume of liquid is less than volume of solid. If mass is constant, mass of the substance is constant, mass of V solid, mass of V liquid, liquid volume is less, so density will be more. Okay, liquid volume is less, so density will be more. So D of solid will be less than D of liquid. Can I say this? For the first plot, D of solid is less than D of liquid. Is that understood? Please try and understand. Is that understood? एक बार मैं फिर से बताता हूँ. ये point equilibrium है. I am keeping the temperature constant and increasing the pressure. जब मैं pressure increase करता हूँ तो system will move in that direction in which volume is decreasing. So I am increasing the pressure. Plot moves in the direction of liquid. ये liquid के पास आ जाके, so same temperature pressure condition पे if I like join these two plots, I get the liquid state. This is happening because the equilibrium is shifting in the direction where the volume is less. So liquid के तरफ वो shift कर जा रहा है, liquid का volume कम है. अगर liquid का volume कम है, mass constant है, तो density of liquid will be more as compared to density of solid. Okay, so this is very simple. The first plot के लिए हम B आंसर दे देंगे. Second plot के लिए हम क्या करते हैं? So again solid, liquid, gas, temperature को constant रख देते हैं and उसके respect में एक pressure condition लेते हैं. Now increase the pressure to P dash. What do I observe? Which state of matter is being observed? The state of matter observed is that of solid. Okay, so that means the equilibrium is shifting in the direction where volume is less. With that in mind, volume of solid has to be less than volume of liquid. If volume of solid is less than volume of liquid, then density of solid will be more as compared to density of liquid. So density of solid will be more as compared to density of liquid. So B and C would be the right answer to the question. Okay, B and C will be the right answer to the question. Okay, so where this equation PA minus P total by P total is used when you have this is an alternate form of relative lowering of vapor pressure. Okay, there's an alternate form of relative lowering of vapor pressure. You can like identify it on your own as well. Do a mathematical analysis for that. So P naught minus P total by P naught is equal to number of moles. Take the inverse of that equation, you will end up getting the same equation that you're talking about. Okay, the right answer the right answer to this question is B and C. Okay, beautiful question. Let's move ahead. Let's take this question. Okay, so the question is the depression freezing point. The question is from depression freezing point. The depression freezing point of 0.01 molal aqueous solution of acetic acid is 0.02046. Assuming that the molality of the solution is equal to its molarity, then which of the following statements is or are true? How do we solve this question? Okay, so दिया गया है acetic acid 0.01 molal aqueous solution. Depression freezing point is given. You have to what are the options? पहले आप options देख लीजिए. Options are given for degree of dissociation and pH. So it means I have to work around the Van 't Hoff factor. हमें Van 't Hoff factor के ऊपर काम करना होगा इस question को solve करने के लिए. How do I solve the question? I take this equation del TF is equal to I times KF times molality. Okay, del TF is equal to I times KF times molality. Del TF is given as how much? 0.02046. I is unknown. KF value is 1.86. And what is molality? 0.01. What is the value of I? बताइए, what will be the value of I? I क्या है? यार I हमने पहले डिस्कस कर लिया था. I is known as Van 't Hoff factor. Please watch the previous videos to understand this. Okay, so if you are in class 8th, I don't think you will be benefited from this lecture. This is for class 12th. Okay, so what is the value of I? Please tell me what is the value of I. Please, you can calculate it. कितना आंसर आना चाहिए I का? 1.1. Okay, so 1.1 is the value of I. Okay, 1.1 is the value of I. Now acetic acid दिया गया ना. How does acetic acid dissociate? Acetic acid will dissociate to form CH3CO minus plus H plus. Okay, acetic acid will dissociate to form acetate and H plus. So this will, if I take 1 mole of this, it will dissociate to an extent alpha, and this will be alpha and this will be alpha. यही होगा. Okay, 1 minus alpha, alpha and alpha. ठीक है. Now what I have to do is I have to calculate Van 't Hoff factor. What is Van 't Hoff factor? Total number of moles produced divided by total number of moles taken. So initial number of moles taken if was 1. Now the total number of moles present is 1 plus alpha by 1. If I add all of them, I'll get 1 plus alpha by 1. So alpha will be equal to 0.1. Alpha will be equal to 0.1. So degree of dissociation is 0.1. So B option becomes correct. Okay, the B option becomes correct. Degree of dissociation 0.01, ये incorrect है. Degree of dissociation is 0.1. Okay, maybe alpha is 0.1. तरुण, maybe नहीं, alpha is 0.1. Now अब हमें identify करना है कि what is the pH. ठीक है, what is the pH? How to identify pH? So pH को identify करने के लिए I need to know the H plus ion concentration, isn't it? to calculate pH, pH is equal to minus log H plus ion concentration, isn't it? If I multiply it by the concentration C, I will get C alpha, so it will be minus log of C alpha. The value of C is 0.01. ये मोलाल दिया है, but you have to use this statement. Molality is equal to molarity. Okay, molality is equal to molarity. So molarity भी यही हो जाएगी. So molarity will be 10 raised to minus 2, and alpha is 10 raised to minus 1. So pH will be minus log of 10 raised to minus 3. That is 3. The right answer is 3. So the right answer for the solution will be B and C. Okay, not a very difficult question, However, you have to remember that they can mix liquid solutions with any other topic. Okay, they can mix liquid solution with any other topic. ठीक है, 1 नहीं होगा, जिसने 1 बोला है 1 नहीं होगा, क्योंकि pH depends on the concentration and degree of dissociation. So concentration times degree of dissociation का negative log लेंगे, so I'll get the value of pH. Okay, so I hope you have understood this question. B and C would be the right answer. ठीक है, चलिए next question लेते हैं. Okay, next question. Please read the question. ये statements दिए गए हैं and you have to identify which of the following statements is or are. Remember, whenever you are getting a multi-option correct question, okay, can pH be 0? Yes, pH can be 0. pH can be 0. H plus ion concentration is not equal to 10 raised to minus 1 because I was assuming that 1 molar solution is participating in the reaction. But so if 1 molar solution is participating, it will be alpha. If 0.01 is participating, it will be 0.01 times alpha, isn't it? Alpha is the degree of dissociation for 1 mole of a substance or 1 molar solution. So let's look at this question. Which of the following statement is or are correct for ideal binary solution of 2 volatile liquids? Ideal binary solution. Give me an example of an ideal binary solution. Give me an example of an ideal binary solution. Binary means 2 components. 2 components. बताइए क्या होगा? What is the what is an ideal binary solution? Give me an example of an ideal binary solution. Example could be benzene and toluene, CCl4 and SiCl4. We can have H2O HCl will be a non-ideal solution because the substance dissociates. HCl dissociates, so we cannot have H2O HCl. That is impossible. So for this solution, if I take ideal solution, I first need to remember that the ideal solution will always across all concentration values will follow Raoult's law. Hexane and heptane, yes, hexane and heptane, very good. So it will always follow Raoult's law. Okay, so can I say C? First let's look at the C option. The total pressure above the solution is equal to the sum of vapor pressure of 2 pure components. Sum of vapor pressure of 2 pure components. Will this statement be correct or incorrect? Total pressure is equal to the sum of vapor pressure of 2 pure components. It's not correct. It's not correct because it will be the sum of partial pressure of 2 pure components. Okay, it will be the sum of partial pressure of 2 components. So ये incorrect हो जाएगा. Okay, because what we write, P total is equal to P dash of A plus P dash of B, which is mole fraction of A times P naught A plus mole fraction of B times P naught B. Okay. Okay, it's a incorrect option. So this is incorrect. Let's start with the first option. The vapor is always richer in the more volatile component. It's obviously correct. Whatever is more volatile will try to get out of the solution or will produce more vapors. More volatile, more vapor pressure, more partial pressure. So vapor is always richer in the more volatile component. This is correct. ठीक है? अगर आपने दो लिक्विड्स को मिक्स किया है तो जो ज़्यादा वॉलेटाइल होगा उसके ज़्यादा वेपर्स मिलेंगे, एंड ज़्यादा वेपर्स मिलेंगे तो उसका कंपोजिशन वेपर फेज में ज़्यादा रहेगा. The liquid will gradually become richer in the less volatile component if the mixture is distilled. Let's look at the statement very carefully. The liquid का मतलब the liquid which is taking in a distillation flask. When I distill it, whatever is more volatile separates out. Liquid में क्या रह जाता है? Whatever is less volatile. So the liquid will gradually become richer in the less volatile component if the mixture is distilled is also correct. Okay? It is also correct. When I take a mixture of two liquids and I boil them to perform distillation, whatever is more volatile will move out of the solution and whatever is less volatile will remain back. So the liquid refers to whatever is present in the flask which is being heated. Okay, which is being heated. So उसमें कौन सा liquid ज़्यादा present रहेगा? That liquid जिसका vapor pressure कम है, that liquid whose boiling point is higher. क्योंकि जो बाहर निकलेगा उसका boiling point lower होना चाहिए और vapor pressure should be higher. Okay, so the liquid will gradually become richer in the less volatile component if the mixture is distilled. Okay. Next, the boiling point of the solution will be less than the boiling point of the two components. The boiling point of the solution will be less than the boiling point of two components. No, the boiling point, if I plot boiling point, let's say this is boiling point of A and this is boiling point of B, the plot that I obtain will be like this. Okay, so the boiling point, the lowest boiling point in the whole plot, this is mole fraction. The lowest boiling point will be of A, the highest boiling point will be of B. The mixture will have a boiling point between these two things. Okay, so अगर इसका boiling point अगर हम मान लेते हैं 100 है और इसका boiling point अगर हम मान लेते हैं 50 है, then mixture का किसी भी point पे जो boiling point रहेगा वो 50 या 100 के बीच में रहेगा. It will be less, it will not ever be less than 50, it will not ever be greater than 100. Okay. एडवांस के क्वेश्चन नहीं हो पाते हैं तो भाई एडवांस के क्वेश्चन सॉल्व करने के लिए थोड़ा टाइम देना होता है. एडवांस के क्वेश्चन ज़्यादा डिफिकल्ट होंगे एंड एडवांस के क्वेश्चन को सॉल्व करने के लिए आपको एफर्ट्स लगाना पड़ता है. पॉइंट टू पॉइंट क्वेश्चन नहीं होते हैं, दे विल बी ऑलवेज ट्विस्टेड एंड टर्न्ड. ओके, ए एंड बी में से सॉल्वेंट कौन सा है? बोथ ऑफ देम आर सॉल्वेंट्स. ओके, it's a solution of two liquids. Okay, if it is a solid and a liquid solution, I can always have one as solvent, one as solute. But when both of them are mixed, then when both of them are mixed, then I cannot qualify one of them as solvent, other as solute. दोनों ही solvent रहेंगे. Okay, both of them will be treated as solvents. So remember, the boiling point of the solution will be less than boiling point of the two components. No, the boiling point will be between the boiling point of the two components. Okay, the right answer should be A and D. Okay, we have solved this question. Let's look at this one. Okay, let's look at this one. Now this is a question from non-ideal solutions. Okay, this is a question from non-ideal solutions. And can you look at this temperature versus mole fraction plot and tell me that what is happening over here? Let's look at this. A mixture having composition corresponding to point Z, composition कुछ यहाँ पे है. Okay, this is the composition and its boiling point is this. TZ. This is the boiling point of, let's say, A. This is the boiling point of A. Because A का mole fraction यहाँ पे 1 है, so this is like B. Okay. So if you look at the boiling point of the solution at this point, at point Z, at this point, isn't the boiling point of the solution greater than the two components which are mixed? Isn't the boiling point of the solution at point Z greater than the boiling point of B and A? Isn't it? Think carefully, बताइए. आप plot देख के बता सकते हैं. Boiling point अगर हम लें, then boiling point of A is over here, boiling point of B is over here. So isn't the boiling point of point Z more than boiling point of A and B? This is observed, if you remember our discussion on non-ideal solutions, this is observed in a case where we see negative deviation, because vapor pressure decrease करने के कारण boiling point increase कर जाती है. So this is for negative deviation. So A and B, this is for negative deviation. So let's look at the first option. The composition of distillate differs from that of mixture. Okay, the composition of distillate differs from that of mixture. Remember, Z represents a point which is known as azeotropic, क्योंकि इससे ज़्यादा boiling point नहीं हो पा रहा है. And at this point, if we perform distillation, I will obtain the distillate, the vapors in the same composition. So composition of distillate differs from that of mixture. No. जब भी आप azeotropic mixture को boil करते हैं, whenever I identify the composition of azeotropic mixture, whenever I boil a azeotropic mixture, it will produce the vapors in the same composition as it is present in the liquid state. इसको हमेशा याद रखो, इसमें कभी भी change नहीं होगा. This is always gonna work. Okay. Now, distillate differs from that of the mixture? No, ऐसा नहीं होता है. The mixture represents a maximum boiling azeotrope. Yes, maximum boiling is. It's not minimum boiling. Had it been minimum boiling, the minimum boiling plot looks exactly opposite. Minimum boiling looks exactly opposite. The minimum boiling azeotrope means the azeotrope's boiling point will be less than that of A and B. Okay, it will be minimum है sir? नहीं यार, minimum नहीं है. ठीक है, maximum है. The mixture represents maximum boiling azeotrope. ठीक है. At point Z, the vapor pressure is higher than at any other composition. No, if the boiling point is more, then vapor pressure is least than any other composition. Okay, vapor pressure is lesser than any other composition. किसी भी और composition के comparison में इस point पे जो vapor pressure है which is less, because boiling point is maximum. Remember, vapor pressure is inversely proportional to boiling point. अगर वेपर प्रेशर ज़्यादा है तो बॉइलिंग पॉइंट कम. इफ वेपर प्रेशर इज लेस, बॉइलिंग पॉइंट विल बी हायर. सो सी इज ऑल्सो इनकरेक्ट. लेट्स लुक एट द डी ऑप्शन. द मिक्सचर रिप्रेजेंट्स अ मिनिमम बॉइलिंग azeotrope. Nope. So it is quite possible कि you are given a question which looks like a multi-option correct question. उसमें सारे ऑप्शंस करेक्ट हो सकते हैं या फिर सिर्फ एक ही ऑप्शन करेक्ट हो सकता है. सो यू हैव टू एनालाइज ईच एंड एवरी स्टेटमेंट एज अ सेपरेट क्वेश्चन. ओके, द राइट आंसर टू दिस क्वेश्चन विल बी बी. ओके, सो लेट्स मूव फॉरवर्ड. लेट्स टेक दिस क्वेश्चन, एंड दिस क्वेश्चन इज वेरी इंटरेस्टिंग. सर लास्ट में एक बार वेंट ऑफ फैक्टर रिवाइज करा दो प्लीज़. हमने वेंट ऑफ फैक्टर के ऊपर काफ़ी कुछ किया है लोहिता, एंड वी हैव ऑलरेडी डिस्कस्ड वेंट ऑफ फैक्टर. प्लीज़ डू वॉच दैट वीडियो, उसमें हमने काफ़ी क्वेश्चंस डिस्कस किए हैं. ओके, लेट्स डिस्कस दिस क्वेश्चन. क्वेश्चन क्या है? 1 gram ऑफ मोनोबेसिक एसिड व्हेन डिसॉल्व्ड इन 100 gram ऑफ वाटर लोअर्स द फ्रीजिंग पॉइंट बाय दिस वैल्यू. ओके, व्हाट इज द डिग्री ऑफ डिसोसिएशन? हमें डिग्री ऑफ डिसोसिएशन निकालना है. द मोमेंट आई विल गो टू डिग्री ऑफ डिसोसिएशन, आई हैव टू वर्क ऑन विच थिंग? कैन यू प्लीज टेल मी? द मोमेंट आई गो फॉर डिग्री ऑफ डिसोसिएशन, किस कंसेप्ट के ऊपर क्वेश्चन पूछा जा रहा है? वैन हॉफ फैक्टर के ऊपर पूछा जा रहा है, आई के ऊपर पूछा जा रहा है. वेरी गुड हितेश. ओके, इट इज बीइंग आस्क्ड ऑन आई. सो हाउ डू आई सॉल्व द क्वेश्चन? I use this equation del TF because it is about freezing point. So del TF is equal to I times KF times molality. I'll write this. What is the value of del TF? Del TF कितना है? 0.465. What is the value of I? It is unknown. अभी भी I का value मालूम नहीं है हमें. KF value is 1.86. Molality, now it is given weight of monobasic acid. Can you see that the molecular weight is not given? So weight से moles निकालने का तरीका क्या है? Weight is 1 gram by the molecular weight, which is the number of moles, divided by the weight of solvent, that is 0.1 kgs. That will give us the molality. Now this is the equation. Now इस इक्वेशन में आप देख सकते हैं there are two unknowns. Okay, there are two unknowns. I have I which is unknown and molecular weight of solute which is also unknown. If okay, if we have to solve this question, I need to know the value of molecular weight. I need to know the value of molecular weight. How do I obtain the value of molecular weight? I will use the second information. It's given that 0.2 gram of the same acid, if is titrated with NaOH, it requires 40 milliliters of N by 12 NaOH. Okay, so I have to use the equivalent methods, equivalent concept method. Equivalent concept ये कहता है कि मिली इक्विवेलेंट्स ऑफ रिएक्टेंट 1 will be equal to milli equivalent of reactant 2. Okay, milli equivalent of reactant 2. Now milli equivalents will be calculated by using weight. I can use weight by equivalent weight. So 0.2 is the weight of the acid, 0.2 is the weight of the acid, and I divide it by the molecular weight. Okay, I divide it by the molecular weight, and it is already given monobasic. Monobasic का मतलब क्या होता है? It will give out just one proton. It will give out just one proton. If it is giving out just one proton, the N factor will be 1. Okay, and the weight by molecular weight times N factor. Weight by molecular weight is moles times N factor is equivalents. To get milli equivalents, I will multiply it with 1000. Okay, N factor is 1. So this is nothing but moles. I will write over here moles times N factor is equal to equivalents. Is equal to equivalents. Will be equal to milli equivalents of reactant 2. 40 ml is taken. Normality is 1 by 12. What will be 40 times 1 by 12? I do not have to divide by 1000. I have to multiply it with 1000. I am getting equivalents. Okay, weight by molecular weight will give me moles. Moles times N factor will give me equivalents. मुझे milli equivalents चाहिए. To get milli from moles, I have to multiply it with 1000. मिलीलीटर्स कैसे निकालते हो? अगर लीटर दिया है तो मिलीलीटर कैसे निकालोगे? सो लीटर टाइम्स 1000 will give you milliliters. Similarly, equivalents times 1000 will give you milli equivalents. So 40 times 1 by 12. Milliequivalents can also be identified by normality times volume in ml. So can you tell me what is the value of m from this equation? Okay, what is the value of m from this equation? This will be equal to, so 12 to 24 and 4, 6. I think answer should be 60. Kuch 60 grams hona chahiye. Okay, the answer should be 60. If I put the value of 60, I times 1.86 times 1 by 60 times 1 by 0.1, 0.465. Okay, 0.465. What is the value of I that we are getting? Please tell me, what is the value of I that we are getting? This will be equal to, बताइए कितना होना चाहिए? What is the value of I that you are getting? 0.465 is equal to I times 1.86 times 1 by 60 times 1 by 0.1. What is the value of I that we are getting? बताइए, somebody use a calculator. बताओ क्या होना चाहिए? What should be the value of I? कितना हो सकता है? 0.31, 1.47. चलो ठीक है, I'll take 1.47. If I is 1.47, this is acid. Let's say the acid is in the form HA. If the acid is in the form HA, it is giving out H plus A minus. Okay, HA gives out 1 0 0, 1 minus alpha. This will be alpha, this will be alpha. Okay, this will be 1 minus alpha, alpha, alpha. That will be the number of ions produced of each of them, and this will be the amount of substance which is left out. So I will be equal to 1 minus alpha plus alpha by 1, which is equal to 1 plus alpha. I is given as 1.47, so alpha will be equal to 0.47. ठीक है? Clear? So it will be alpha is 0.47. Clear? Just look at the value of I. Somebody is saying that it is 1.5. If it is 1 point, तो alpha हो जाएगा 0.5. If I is 1.47, alpha will become 0.47. ठीक है? So remember, advanced questions are not very difficult. Advanced questions do require a conceptual understanding, a very thorough conceptual understanding of that topic plus other topics as well. क्योंकि आप देखें कि to solve certain questions we used to get to the final answer, to get to the answers that the question is demanding, not only liquid solutions, I had to use ionic equilibrium as well. Okay, so it is important that you focus on everything equally. Liquid solutions easy है तो ठीक है, अगर वो easy लग रहा है तो वो difficult भी बनाया जा सकता है. So by mixing titration with it, by mixing non-ideal solutions plots with it, and by mixing ionic equilibrium with it. Okay, so the next session will be of Pulkit sir, who will teach inverse trigonometric functions. This is lecture 4 on that, and please do like, share and subscribe our channel. That's a very big please to you guys, and please do join us for the next session. The next session we will be starting with electrochemistry. Okay, easy topic है, थोड़ा सा इधर उधर कहीं कहीं फंसते हैं लोग, but we will try to like work through it. Next session will be on electrochemistry. ठीक है? So this is Saurav Sir signing off, and I wish you all the very best and have a lovely day ahead. Bye bye guys.